Hello everyone and welcome back to another video. In this video, I'm going to show you on how you can make an internet-based unlimited range telemetry for your Pixhawk drone, including the live video streaming capability. So in one of my earlier videos, I've already shown you on how you can make a cheap ESP8266 based Wi-Fi telemetry, but that was limited within a very short range. I mean, that was limited at most within 100 meters. But in this case, I've used the Mavlink protocol to forward the telemetry data over 4G or LTE network. That means eventually you can have access over your telemetry data and keep connected with your drone using your GCS or ground control station simply from anywhere of the world, provided that the 4G or LTE network is available. So initially I'll be giving an overview of my entire system. After that, I will describe the components that I've used here. Then I'll show you the connection diagram or the wiring between my flight computer and my flight controller, which are respectively the Raspberry Pi and the Radio Links Pixhawk. After that, I will show you on how you can install the configuration script, cloning the GitHub repository. And finally, I will show you the live demonstration with the live video streaming. So right now, I'd like to give an overview of my entire system. I'll be using the Mavlink protocol to communicate between the flight controller and the flight computer, which are respectively the Radio Links Pixhawk and the Raspberry Pi in my case. Thanks to this GitHub repo by Alireza, Mavlink-Anywhere, that will be eventually allowing us to configure the Mavlink router very easily. So the problem is, how do we forward the telemetry data extracted by the Raspberry Pi from the flight controller using the Mavlink protocol? Well, to serve that purpose, we will be connecting both the Raspberry Pi as well the ground control station. I mean the device having the ground control station installed. In my case, I'm using Mission Planner on my laptop, so I'll be connecting the Raspberry Pi as well my laptop to the same virtual private network that will eventually allow us to forward the telemetry data from the Raspberry Pi through the virtual private network all the way up to the ground control station. So I'll be using Netbird to serve that purpose. You simply have to create an account and add all of your devices. For example, as I have my ground control station in my laptop, I have to add my laptop here. So you click here, add peer, and then install Netbird on your on Windows. You simply follow the instructions. You might be asked for authentication purpose. You might be asked to click on a link, or a window may pop out in your browser automatically, and you have to do the same in case of the Raspberry Pi. But in that case, you have to click on the Linux option, because the Raspberry Pi operating system is mainly Linux based. So you have to run this command in the CLI of the Raspberry Pi and simply follow the instructions. Maybe once the installation is over, they will give you a link that you might have to click for authorizing your device to Netbird, and simply click on Netbird up for connecting to the virtual private network and Netbird down for disconnecting from the virtual private network. So that's all about the connection part on Netbird. So the Raspberry Pi will be connected. So as the Raspberry Pi as well the ground control station, the device having the ground control stations are connected with the Netbird, followed by the instructions that I've already told you. You will see that you will see a Netbird IP below each of these devices. So it will be very important to note down these IP address, as we will need them to forward the telemetry data as well for live video streaming. I have two Raspberry Pis here, as you can see, the Raspberry Pi 5 and the Raspberry Pi 02W. For this part, I'll be using the Raspberry Pi 02W, but in case of the computer vision intensive task, I usually use the Raspberry Pi 5. But I've done the same configuration on both the Raspberry Pi 5 as well the Raspberry Pi 02W. In case of Lite works like for just simply forwarding the telemetry data, and for video transmission purpose, it's better to use the Raspberry Pi 02W, as it's very compact and lightweight. So it's very simple. The extracted telemetry data by the Raspberry Pi would be forwarded to the ground control station via Netbird. So we will be needing the Netbird IPs of both the Raspberry Pi as well the laptop, as I've told you. In fact, the Raspberry Pi will be forwarding the telemetry data to the Netbird IP of our laptop, and then by choosing the proper UTP endpoints, we would easily be able to connect with the drone from Mission Planner. I'll be showing you the configuration part very shortly. So that's all about the overview of my entire system. In the next part, I'm going to be describing the components that I've used here.
So right now I'd like to describe the component that I've used here. So as a flight computer, I have used the Raspberry Pi 02W, as I've already told you, but I've also run the same configuration on the Raspberry Pi 5 that I mostly use for computer vision extensive task. But for this part of the video, as I'm only limited within forwarding the telemetry data over 4G and the live video streaming, I prefer using the Raspberry Pi 02W as it's very compact and lightweight. As the camera module, I have used the Raspberry Pi camera module V3. This is the NoIR version. That means you can capture good quality photos at low light condition. As well, in the dark, it's able to capture photos in presence of infrared illumination. Now, the Raspberry Pi must be connected with internet in order to forward the telemetry data over 4G or LTE. So to serve that purpose, I have used a 4G Wi-Fi modem, as you can see here, and there is a SIM card inside the modem. And the modem is connected to the Raspberry Pi by means of OTG or USB on the go. This will eventually ensure stable internet connection to the Raspberry Pi during the flight. So the Raspberry Pi can connect with the internet either by means of Ethernet or by means of the Wi-Fi generated by this Wi-Fi modem, as you can see here. Another additional component that I would like to talk about is the buck converter LM25 DC-DC buck converter LM2596. So the Raspberry Pi has to be powered with 5 volts, but the 4-cell lithium-ion battery pack on board my drone generates around 16.8 volts once they are completely charged. So I must be using something else for powering up my Raspberry Pi. So I've stepped down the voltage using a DC-DC buck converter LM2596, as I've already told you, and adjusted the potentiometer of the buck converter. As such, it gives output 5 volt, and using that 5 volt, I powered the Raspberry Pi. That will be eventually powering up the USB Wi-Fi dongle. So that's all about the component that I've used here. Finally, I have attached all these components with each other this way using the rubber bands and the ribbon cables. As you can see, this is the back view, this is the side view, this is the top view, and finally I have tied everything, fitted everything on board the drone using the rubber bands and the ribbons, as you can see here. So in the next part, I would like to talk about the connection diagram between the Pixhawk and the Raspberry Pi. So right now I'm going to be explaining the connection diagram between the Pixhawk flight controller and the Raspberry Pi. Be careful about the orientation of the flight controller, otherwise you may confuse with the pins of the telemetry 1 port. So I'll be using the telemetry 1 port to connect the Pixhawk flight controller with the Raspberry Pi, but if you want, you can also use the telemetry 2 port. So I'll be crossing the transmitter and the receiver of the telemetry 1 port with the Raspberry Pi 02W that I'm using here. So let me explain the ports within the telemetry 1 port, the pins within the telemetry 1 port, I should say. So the leftmost pin, as you can see, that I've marked with the red arrow, this one is the VCC pin, and the rightmost pin, as you can see, marked with the black arrow, is the ground pin. The orange one is the transmitter, and the green one is the receiver of the Pixhawk flight controller, which is eventually to be crossed with the Raspberry Pi. That means the transmitter pin of the telemetry 1 port is to be connected with the receiver of the Raspberry Pi, and the receiver pin of the telemetry 1 port is to be connected with the transmitter pin of the Raspberry Pi. It's also very important to ensure that you are shorting the ground between the Pixhawk and the Raspberry Pi. So to serve that purpose, you have to get a wire out from the telemetry 1 from the ground pin of the telemetry 1 port and connect it with the ground of the Raspberry Pi. I believe this is the ground pin of the Raspberry Pi. You can check out the ground pins from the pinout of the Raspberry Pi 02W. As you can see the pinout here, this one is the ground, this one is ground, all these grounds are shorted, this one. It's up to your own wish to which pin you'd like to connect the ground. So if you're not sure about the amount of power that your flight controller can supply, in my case the Pixhawk, Radio Link's Pixhawk, is not able to supply enough power so that the Raspberry Pi can run smoothly. In that case, I had to use an external power supply to power up the Raspberry Pi, as I've already told you in the previous part that I've used that I've used a DC-DC buck converter LM2596 to step down the voltage from my lithium-ion battery pack that will be eventually powering up my drone to 5 volt, and I have powered the Raspberry Pi with that 5 volt. So the VCC pin, the positive pin of my BEC is connected with the 5 volt pin of the Raspberry Pi, and the ground pin is connected with the ground pin of the Raspberry Pi, as you can see. So this is the ground of the power supply, and this one is the ground of the telemetry 1 port. So all these things must be shorted with each other. What I want to say, don't forget to short the ground of the Pixhawk flight controller with the Raspberry Pi. So that's all about the connection diagram between the Pixhawk and the Raspberry Pi. Another thing I would like to mention is that the telemetry 1 port connects with DF13 connector, but the Raspberry Pi comes with the male header pins. So you have to make a converter using the DF13 connectors so that you can easily connect the telemetry 1 port with the Raspberry Pi. So here is the pinout of the Raspberry Pi 02W, and it works the same. The scenario is same for Raspberry Pi 5 as well. As you can see that the 5 volt ground pins are available here. So you have to short the ground of the Raspberry Pi 5 with the ground pin of the telemetry 1 port, and as you can see that the transmitter and the receiver pin, which are to be crossed with the telemetry 1 port of the with the transmitter and the receiver of the telemetry 1 port of the Pixhawk flight controller. So that's all about the very simple connection diagram. Another thing that I might have forgotten to mention is that the I believe you can see that the entire configuration looks like this finally. Another thing that I'd like to mention is that the CSI cable, which is the camera serial interface cable that comes with the Raspberry Pi camera module V3, is not compatible with Raspberry Pi 02W or the Raspberry Pi 5. So to serve that purpose, you have to buy another CSI cable so that you can easily connect the camera with your Raspberry Pi. So that's all about the connection diagram. In the next part, I will be showing you the configuration script that you have to install in order to forward the telemetry data to the ground control station from the flight controller using the Raspberry Pi over 4G or LTE network. So right now I'm going to be showing you the installation scripts that you have to run in order to install the Mavlink router on the Raspberry Pi 02W. So initially you have to flash the operating system on the Raspberry Pi. So choose your device and then select the operating system. Well, the Raspberry Pi 02W comes with a limited amount of RAM, which is 512 megabytes. So I highly recommend not to install the complete desktop environment because that will consume more amount of RAM as well CPU. So I suggest installing the Raspberry Pi OS Lite 64 version that doesn't come with any kind of desktop version, eventually leaving free amount of RAM as well CPU. And then you have to choose the device where you'll be flashing the operating system, and simply plug in the SD card on the Raspberry Pi 02W and boot up your device. You can find plenty of videos online regarding the flashing of the operating system on the Raspberry Pi. So right now, before proceeding with this step, you must ensure that you have connected both the Raspberry Pi Zero as well your laptop with Netbird. As you can see that that both of the devices are online. So before proceeding with this step, make sure that both of the devices are connected on Netbird. So it's very important to note down the Netbird IPs, as I've already told you. So right now I have to connect with the Raspberry Pi, with my Raspberry Pi, and I'll be doing so by means of SSH. And I'll be using the Netbird IP of the Pi because this will eventually allow me to SSH the Raspberry Pi remotely from anywhere. So I can also use this Netbird IP to forward the, for a live video streaming purpose, as I'll be showing you in the next part. So right now I'm gonna SSH to the Raspberry Pi using the Netbird IP. So I'm opening my command line interface and SSH to the Raspberry Pi using the Netbird IP. I'm entering my password. As you can see that I'm inside my Raspberry Pi. So initially you have to run some generic commands like sudo apt update and sudo apt upgrade that will ensure that all the packages are up to date.
Then you have to follow all the steps that are mentioned in the GitHub repo Mavlink-Anywhere. Thanks to Alireza for this repo that will eventually allow us to install the Mavlink router without any hassle. So all the steps are very clearly mentioned here, and all the commands that you have to run are also given. For example, first of all, you have to clone the repo. I've already cloned it, so I'm directly seeding to the Mavlink-Anywhere directory. Then you have to run the installation script. Well, I'm not going to be running the installation script since I've already since I really don't want to overwrite my installation files. But in your case, you have to go through this step, and it will take quite a while, as the Raspberry Pi Zero 2W comes with a limited RAM as well CPU processing as compared to the Raspberry Pi 5. So be patient once you are running the script, once you are running the installation script on the Raspberry Pi Zero 2W, as it might take quite a while. So over here you can see that it tells everything the command does, and then you have to run the configuration script. So I've copied these commands. I will be attaching the link of this GitHub repo as well, all these commands in the description box, as you can find below. So I'm running the configuration script, and as you can see, there are a number of steps that it has told you have to go through initially. For example, you have to run the sudo raspi config command, then navigate to the interface options to serial port, and then disable the serial console and enable the serial port hardware. Reboot the Raspberry Pi so that the changes may take effect. You have to be through these steps before coming to this stage. So as I've already done so, I'm not going to be doing it for one more time. So I'm hitting on enter to continue. Then you have to insert the UART device. For example, I'm using the Raspberry Pi Zero 2W, so the device ID is TTYS0. But if you're using the Raspberry Pi 5, then the device ID will be something like this one. You have to copy this line and paste it out there. As you are using different other devices, then you have to search for the device ID, for the UART ID, and paste it right over here. So this one will change TTYS0. It varies from device to device. So I'm not going to be making any kind of changes. So I'm going to be hitting on enter. You have to enter the UART baud rate. So I've chosen 921/600, and the same baud rate is to be chosen in the mission planner from the full parameter list under the section serial 1 baud rate. I will be showing that very shortly. And then you have to choose the UDP endpoints. For example, in my case, I'm forwarding the telemetry data to the Netbird IP of my laptop. As you can see that the Netbird IP of my laptop is this one, ending with 221. As well, over here, as you can see that the Netbird IP is 221, followed by the UDP endpoint. Now, if you have multiple ground control stations, for example, you have mission planner in your laptop as well in your cell phone, then you can insert multiple IPs by separated by spaces. So you have to insert, if you want to, then you can add multiple devices. In my case, I'm only using my laptop, so I've inserted so you have to insert the IP address, Netbird IP address of your laptop, where the ground control station is installed and where the telemetry data would eventually be forwarded, colon the UDP endpoint. That is, the UDP endpoint is followed by the Netbird IP address of the device where the ground control station is installed. In my case, it's my laptop, and my ground control station is mission planner. So if you have multiple IPs, multiple devices, then simply do the same thing, separated by spaces. Then hit on enter, and as you can see that it has already done all the configuration stuffs. So you can see the device ID, the baud rate, the UDP endpoint, the mode, and the IP address, followed by the port, followed by the UDP endpoint. So right now, as we are done with the configuration script, as I open the mission planner, I must be connecting to the drone. So let's see if the telemetry data is being forwarded. So I'm opening mission planner. Let's wait a while until it's being opened. Okay, it will be opening very shortly, and we would be connecting as well. Okay, what's wrong with it? I don't want to update now. Okay, as you can see that we are already connected to the drone by means of UDP. So you can see that the UDP endpoint is 14550, the same that we have chosen during the configuration
while running the configuration script. So for the sake of clarification, let me change the yaw of the drone and show you if it's changing. As you can see that the yaw is changing, the heading, everything is changing. Well, the yaw cannot be seen here. You can see that the heading, I'm moving it to the right, I'm moving it to the left, I'm moving it up and down. As you can see, it's changing. So I believe that I have been able to make myself clear enough. Another thing that I would like to show you is the baud rate that you have to choose from the full parameter list. So you have to go to configuration, full parameter list, and then look for serial 1 baud rate. So serial 1, as you can see that the serial 1 baud rate is 921.600, the same one that we used in the configuration script. As you can see, 921.600. So these two must be same so that the telemetry data can be forwarded. So I believe that I have been able to make myself clear enough. This will eventually allow you with unlimited range telemetry, and you can control the drone literally from anywhere. You can also connect the radio transmitter as a joystick with a mission planner and control it remotely, control the drone remotely, which is not suggested as it's very risky. And let me show you if the flight mode changes. So let me change the flight mode to alt hold. As you can see that the flight mode has been changed to alt hold. Let me change the flight mode to something else like stabilize. As you can see that the flight mode has been changed. So the telemetry over 4G is perfectly working. So that's how it works. In the next part, I'm going to be showing you on how you can stream the live video footage. Right now, I'm going to show you on how you can stream the live video footage using the Raspberry Pi and the Raspberry Pi camera module V3. So before proceeding with this step, make sure that you have both of your Raspberry Pi as well your laptop connected to Netbird, as we'll be requiring the Netbird IPs of the laptop as well of the Raspberry Pi to stream the video. There are a number of approaches that you can follow, and there is a documentation by Raspberry Pi. You can go through this if you want, and I'll be attaching the link of the documentation in the description box below. So you have to run 2 commands to stream the live video footage from the drone up to the laptop, and make sure that you have ffplay installed in your laptop. You can find a number of documentations online regarding the installation process of ffplay. So as you can see, you have to run this command on the Raspberry Pi and either of these 2 commands on your laptop. The first one offers lower latency, the greater latency, and the second one offers slightly lower latency. As you can see, you can adjust the resolution of the video transmission, the width, the height, and the FPS or the frame per second. In my case, I'm using a lower resolution, a lower FPS, since my internet connection is not that much stable. But you can try on any of these resolutions, provided that you have the higher resolutions, provided that you have a stable internet connection. So this is the IP address of the laptop where the video would be transmitted, and this is the IP address of the Raspberry Pi where from where the video would be transmitted. So you can think it like the Raspberry Pi and the laptop are communicating with each other. They are talking to each other. So this is the IP address of the laptop to which the Raspberry Pi is talking, and this is the IP address of the Raspberry Pi to which the laptop is listening to. So with no delay, I would like to run this command. So this one has to be run on the Raspberry Pi. So as you can see that the video transmission has initiated from the log, as you can see, and then you have to run the later command on a separated command window. So I'm pasting this, and the video transmission should be initiated shortly, and a window should pop up. So as you can see that we have a window popping up, and I believe you can see my hand. It's not that much clear since I'm using the night vision camera and the resolution is also very low. So I believe you can see that I have moved the camera, moved the drone, and I believe that you can see my laptop and the other stuffs. So the video transmission is working pretty well. Let me get my hand below the camera. I believe you can see my hand. There might be slightly lags in the video transmission since I've already told you that the internet connection is not that much stable due to bad weather condition outside. So that's how the transmission works. I believe I have been able to make myself clear enough, and you can get unlimited range video transmission followed by this approach. So that's all for now. I believe that I have been able to make myself clear enough. Thanks for watching. Stay tuned for the next one. Bye for now.